Good morning, everyone. I'm Uma Maheshwari, Assistant Professor, Department of Electronics and Communication Engineering. In this lecture series, in this particular video, I'm going to explain about what is meant by equalization. Equalization is nothing but the process to remove intersymbol interference and noise effects from the channel. It is located at the receiver end of the channel. The goal of the equalization is to mitigate the effects of ISI. However, this goal must be balanced so that in the process of removing ISI, the noise power in the received signal is not enhanced. Equalization is a technique which is used to combat intersymbol interference. An equalizer within a receiver compensates for the average range of the expected channel amplitude and delay characteristics. Equalizers must be adaptive as the channel is generally unknown and time varying. ISA has been recognized as the major obstacle to high-speed data transmission over the mobile radio channels. Equalizer. This is the diagram of equalization where the channel, the incoming signal is x of t, and it is equalized with the 4-level pulse amplitude modulation sequence, and it is given to the channel, and finally it is given to the noise n of t, and will be getting the received signal like distortion. The goal of the equalizers is to eliminate intersymbol interference and the additive noise as much as possible. Intersymbol interference arises because of the spreading of a transmission pulse due to the dispersive nature of the channel, which results in overlap of the adjacent pulses. There is a 4-level pulse amplitude modulated signal x of t. This signal is transmitted through the channel with the response of a h of t. Then the noise n of t is added. The result signal r of t is a output signal. So there are the categories of equalization are overcome the negative effects of the channel. In general, equalization is partitioned into two broad categories. One is a maximum likelihood sequence estimation. Another one is equalization with the filters. Maximum likelihood sequence estimation, which entails making measurement of channel inputs, channel impulse response, and then providing a means for the adjustment of the receiver to the transmission environment. The best example for this is a Viterbi equalization. The next one is equalization with filters. It uses filters to compensate the distorted pulse, where the general channel and the equalizer pair is shown here. Here in the step 1, first the waveform is converted to the sample transformation, which uses demodulation and the sampling. The first one is frequency down conversion, where it first converts the bandpass signals frequency using down conversion method. Then it is being given to the receiving filter, and finally to the equalizing filter, where equalizing filter mainly compensates for channel which is induced in the ISI. Then it is being given to the threshold comparison, that is the decision making device. It detects where from the received waveform is nothing but r of t, and the receiving filter will give the bandpass pulse which is possibly distorted. From the equalizing filter will be getting the baseband pulse, and where the t mainly thresholds, if it is 0 it will be closed, it will be a closed switch. If it is 1, the sample will be tested here using the test statistics. Then ISI is due to the filtering effect of the communication channel. Example, wireless channels, where the channels behave like band limited filters, HCFF, which is equal to HCFF e power j theta c into f. That particular part is called as a non-constant amplitude, that is amplitude distortion, where e power j theta c of f is called as a non-linear phase distortion. Baseband system model is shown here, and the equivalent model for that is also shown in the diagram. There are various types of equalizer, that is linear, non-linear, where linear is being divided into transversal lattice and non-linear is divided into MLSME, RMS, RLS, LMS, and square root RLS. Likewise, the equalization techniques is being classified. Maximum likelihood sequence estimation, filtering in that transversal filtering, where zero forcing equalizer and the minimum mean square error equalizer. In decision feedback, using the past decisions to remove the ISA contributed by them. Then the adaptive equalizer. Linear transversal equalizer diagram is shown here, where FIR filter and the IAR filter. This is the diagram of a transversal filter. Then the zero crossing filter, mean square filter. Then the assessment is nothing but a equalization, a definition of the equalization and what are the types of equalizer techniques. Thank you.